Okay, so the data type followed by square brackets and then array name and then is equals to new of data type followed by square brackets and then we mention our size. Okay, so we can create an array of our objects as well. So let's say account record array, we can create it this way. Case record and position, our position record array as well. So we can create the arrays, and by using the index positions, we assign the values to the arrays. So index position for array starts with 0. So if it has 5 elements, it's 0 to 4. Okay, and retrieving the values, we can retrieve the values of a specified index. We can retrieve, any element within the array by making use of the indexes. But if we want to display complete array, we can do that. The thing is, it will display the records in a single line separated by commas. Okay. And the size method is given to us as part of our arrays, which gives the size of our array. So if you want to display all the elements, we just give the array name without any index positions. It will display all the elements in one single line separated by commas. And we have done an exercise of how we are creating an array, assigning values to an array, and then printing the array in single line, printing the array elements in multiple, each element in a new line, and printing the each element in a new line, making use of the for loop. Okay, so this for loop is our normal for loop, which is present in any other programming language. Initialization and condition and then increment or decrement operator. Okay, so this is normal for loop, and we have, as part of Apex, we have another for loop called enhanced for loop. So the left side we define the variable and the right side we supply the collection type, may it be array, list, or map. Yeah, we are going to discuss those later. Okay, so this is how an enhanced for loop looks. So the drawbacks of it is we cannot do the reverse traversal with the enhanced for loop. We can only do the forward traversal, but in general, real-time scenarios, it's mostly the forward traversal we need, and that's where we make use of enhanced for loop, and it optimizes the code, so we don't need to declare the increment decrement operator or something. Okay, so we are not doing that also. So that's how we use it, and it's very easy to use. So that's where regular for loop is little, lesser. How can I say that? Enhanced for loop is little optimized than the normal for loop. But in case we need to do a reverse traversal, probably the normal for loop is only the option for us. Of course, we can go with other iterative statements like while. Okay, so yeah, this is all about the previous class. So let's go ahead. So today we are going to discuss something on uh, object-oriented programming. Okay, so yes, as we already discussed, Apex is an object-oriented programming language. That means anything in the Apex, we define it in the classes, and we make use of the objects from classes, and then we write our program. Okay, so that's where. Like Java, Apex is also object-oriented programming language in which any real world entity is treated as an object. Okay, so object has a class, and class defines the prototype or a blueprint of an object. Okay, so let's take an example. What is in front of you? Let's take, you're sitting on a chair. So chair is an object, right? Right. So chair is, so chair is an object or class? So it's a class. Yes, it chair is an object, but it's a the chair has a class. Okay. How can I say that? Let's say you are sitting on some chair. Let's say I'm sitting on a chair which is having wheels. Okay, so this is one type of chair. And let's say somebody is sitting on a plastic chair. It's also a chair, right? So the class is chair, but it has its own objects. So the chair will have members or properties like it has legs, it has hands, or it has the base to be sit on. So these are the properties. So every chair usually will have these properties. Okay. So chair is a class of which the chair which you are sitting or which I am sitting is an object of a chair class. Okay, that means the class is just a prototype, okay, or a blueprint which says some members, some properties of that particular objects which can be derived from this class. Okay, so anything can be a class. Let's say we are all. Ramiza, can you go and mute if you're not speaking? Right. So right. So we are also a class, human beings, right? So let's say, mm, let's say we have Samant here. So let's say we have Charan here or Srikant here. Let's say we are all belongs to a class called human being. Okay. So that means we all have similar type of properties as we have those properties for a human being. So human being is a class and you and me are objects of human being class. Okay. So that's where I can, in a layman terms, I can say that, or a simple analogy, I would say. Okay. So hope you are understanding what a class is, what an object is, right? So as we said, our Apex is object oriented, where we deal with classes and objects, and class is nothing but any blueprint or a prototype or which defines the basic things. Okay, a class can include a group of variables in terms of our Apex programming. I'm saying, so group of variables, procedures or functions, properties and constructors inside it. So classes are used to implement the custom business logics. And okay, so once you have defined the required members of the class, you can instantiate an object of the class. So object is nothing but it's an instance of a class. That means a class cannot exist physically, but an instance of a class can exist physically, that is object. Okay. So if I say human being doesn't exist physically, okay, but an instance of human being, that is you or me, the object of human being exists physically, right? So that is how we can understand. Okay. So to access this class members, that is the properties of a class, we will be instantiating an object of the class. one class can have more than one objects, right? So chair, as I said so there is one different type of chair which you are sitting, and there is one different type of chair which I am sitting. Okay. And when we take example of our human being class, you are different and an object of human being class. I'm different, an object of human being class, right? So it's like that. Okay. So each object holds a set of values for its class members, and it holds the memory. Okay. So the drawback of our arrays is it can hold only homogeneous type of data types. And also there is a memory wastage because we will have to define the array size initially. So we are not sure whether we are going to make use of the complete memory we defined or not, right? So those are the drawbacks which we can overcome with the help of our classes, also classes and objects. So class and object is a heterogeneous type of data type. Okay. So you can define whatever data types within a class. Yes, you are allowed to define. So each object will have its own amount of memory because objects purely support dynamic memory allocation. Okay. So in our arrays, it was static allocation, right? So we will have to define our size initially. So it was static. We can't change the size also. That was the problem with the array, right? Whereas when it comes to objects, it's a dynamically allocated. So the memory allocation is dynamical. And so here, if I see a class, let's take a class of human being. Let's say name or date of birth. So there were multiple properties like this, let's say. Okay. So this is a human being class where I have a newly born child. Okay. So let's say his name is some Sai. Okay. And his date of birth is today. Okay. 2nd May 2023. And age, it's 1 day old, right? So we have a couple of properties which were derived from our class called human being. And this object, the small kid who was born today, is an object of the class human being, and he's having all the properties of the class human being. Of course, there were some properties like employee name, employee ID, or something like that. Let's say human being class. Those will be acting as not applicable for our newborn baby for today, right? So those properties we are not making use of it. Okay. So that's where we can derive, we can make use of the properties of a class, and we can also, so all the objects which are of type this human being class will have the same uh, members, the class members. Okay, the variables or the methods which are present, all of them can acquire the same qualities. Okay, so that's how we can define our class and our object. Okay, so this is just a basic of classes and objects. So let's have a look at the nodes. Right. So as we are discussing, Apex is object oriented. It is not, procedure oriented or message oriented. It is object oriented. And yeah, in object oriented programming language, we make use of everything, the business logic in the form of classes and objects. Okay. So class, when I say class is nothing but a physical entity, blueprint or prototype, which contains a set of members inside it. A class can include group of variables, procedures, functions, properties, constructors inside it. Yeah, what are all these things we will discuss in detail, right? So variables we already discussed, so we can define the member variables. And procedures, functions, yes, we will discuss. Properties, we will discuss. Constructors, yes, we can discuss. Classes are used to implement custom business logics, hence these are also called controller. Okay, so these are used to implement the custom business logic. So that's why we call the class as the controller classes. So let's say our um, helper class, which helps in writing out the candidate details. So something like that. So we will discuss in detail. 1 second, I'm getting a call. I'm sorry, I had to take that call. So yeah, so object, once the class has been defined with the required members to access the members of the class, we need to access members, we need to reference a key or instantiate an object for the class. Okay, so to access the members of the class, we will be creating an object for that particular class, and then only we will be able to access the members of the class. Objects are used to access class members. We can assign retrieve values. Okay, yeah, this we are going to discuss. A class can have one or more objects. Each object will hold set of values for class members. Each object contains its own memory allocation, and yeah, it's a dynamic memory allocation. Okay, so this can object can hold any type of data type. It is heterogeneous data types. It can hold it. It can support dynamic memory allocation, and there is no memory wastage here. So yes, these are all the important things about objects. Right. Let's go to our object-oriented programming principles. I hope few of these principles you should be aware, right? Right. So because these are again for any type of object-oriented programming language, you will have the same principles. So I am guessing you have a little exposure on Java. If not, yes, we can discuss in detail or as well. So don't worry, I will explain everything in detail. Right. So Apex supports the below four object-oriented principles, that is encapsulation, abstraction, inheritance, and polymorphism. Okay. So encapsulation means uh, we can group a certain. So let's take an example of our class. Okay. So we can group our business logic together in one single helper class. Okay. So where we can instantiate this particular business logic or this particular class, we can use it in multiple places as well. Okay. So it allows us to group a set of related functionalities together into a single entity. Encapsulation can be achieved with the help of classes and interfaces. So yes, so the business logic which we are going to implement, we can group it in one single class, and this class can be used in multiple places wherever required. So that's what called encapsulation. So grouping related functionalities together is called encapsulation. Okay. So abstraction. So yes, I hope you would have all done your project works in your or thesis work in your current studies or the previous studies. Yeah. So initially, while we are starting doing while we start doing our project work or thesis, so we were asked to submit an abstract, right? So abstract is nothing but it contains the main idea, and it shows up only the important things which are needed, but it hides the uh, you know complete working model or the complete details, right? So abstract provides the user interfaces to the people, but without providing the complexity of information. By using abstraction, we can achieve data hiding, right? So I hope, let's take a simple example. Let's say, I hope you all make use of WhatsApp on a daily basis. Yes, right? So, okay. So we know how to send message, how to call, how to create a broadcast group, or how to send messages to uh, the groups which we are present in. So yeah, we know all these functionalities in our WhatsApp, right? But do you know what kind of uh, encryption technology the WhatsApp is using? Do you know what kind of security measures the WhatsApp is using? What kind of programming, backend programming the WhatsApp is using? So we do not know these details, right? So that means it's abstraction. So we know whatever is needed. We are least bothered about the internal details of how WhatsApp is designed, right? So that's what a general simple analogy I would say. So it's an example of abstraction showing the necessary details and hiding the detailed information or the background is called abstraction. Okay, yeah, abstraction we can achieve with the help of defining interfaces, I would say, and then constructors. Okay, so they define the body, the skeleton of the programming, but they are not implementing the actual business logic. They are just defining. Okay, and in our class, if we want to implement them, yeah, we are going to make use of the interface name and then implement that particular interface in our class. Okay, yeah, that is about abstraction. So let's see, next one is inheritance. Inheritance allows us to acquire access features of one class into another so that we can avoid redundant code inside the application. By using inheritance, we can achieve the reusability. So yes, so inheritance, when I say uh, it's a general term, I would say. So a parent and a child. So the child acquires some of the qualities from the parent, right? So it's general analogy. Whereas in our whereas in our Apex programming language, so yes, we are going to use the inheritance by creating the parent class and the child class, just because we are going to get some business logic which is implemented in the parent class. That uh, business logic or that properties, that class members, we are going to inherit to our child class. Okay, so that's where we are making use of we are doing a reusability, as well as we are avoiding duplication of the business logic, right? So that is called inheritance. That means we can define a class, and then we can also define a child class for this class, which inherits the properties of the parent class. Okay, right. So this is about inheritance. So the next one is polymorphism. So polymorphism allows us to create multiple functions with the same name. Right. So polymorphism in the sense, poly means many, forms means morphism means forms. Okay. So that means it can exist in many forms. So let's say method, a single method can exist in multiple forms. Okay. So the functions will be differentiated with the number of parameters, order of parameters, and the type of parameters. Okay, we have below two types of polymorphisms in Apex programming: compile time polymorphism, early binding or static binding, implemented by using overloading feature. So that's called method overloading or constructor overloading. Okay. Yeah, we will be writing this code for this particular overloading also in the coming classes so that you will understand in detail. So runtime polymorphism is overriding. So implemented by using method overriding feature. Okay. So that means we can define a method. Uh, let's say I wanted to create a method called add. Okay. So let's go. So let's say I wanted to define a method called add, right? And this add method, I want to define it in different forms, right? So this is one form for my add method. Let's say I want to different forms with, let's say, integer a, b, integer c. So this is one other form. I want to add some other form. String Okay, so what I'm trying to do is I wanted to show you method overloading. Okay, so here if you see, I wanted to overload my method called add method. Okay, so yes, this is the method. So I did one kind of implementation saying when two integer parameters are passed, I want to implement this particular method. When three integer parameters are passed, I want to implement this particular method. And when two string parameters are passed, I want to implement this particular method. So addition means in strings, it's going to just concatenate. Okay. Oh yeah, this is called method overriding. Okay. So similarly, we can do, sorry, this is method overloading. Okay. So similarly, we can do overriding as well. Yes, we will discuss in detail about method overloading and method overriding in our programming. Okay. Right. I just want to give you a simple thing. So these are all the four principles of our object-oriented programming. So encapsulation, it means showing all the, grouping all the related functionalities together. Abstraction, hiding the internal details and showing only whatever is necessary. Inheritance. So one class can acquire the features of other class. Uh, that means with the help of inheritance, so that we make use of reuse the code as well as we reduce the complexity, or we are making use of business requirement again, right? So that is inheritance and polymorphism existing in many forms as we were discussing. So we can do the compile time polymorphism with method overloading. So yes, our additional method, add method, which I showed now, and the runtime polymorphism using the method overriding. Yes, we can do that. Okay, right. So let's discuss more on our class. So our class will have one or more members inside it, which includes variables, procedures. Yep. So we create one or more classes inside the organization to implement the custom business logics. And each Apex class, once we define, it is going to be saved with extension .apxc, and all the classes which are stored, which we created in our Apex, are going to be stored in a class called Apex class object. Okay. So compiled Apex classes will get stored in metadata repository. So till now, we were doing some programming, which we are doing only on the execute anonymous window. We are not saving it, and we are not, that's where it is not going to store in the metadata repository. But from now on, we will be writing classes code where we are going to save it in the class. And then once we compile it without any compile and runtime errors, then once it is everything is fine, once we have every clean code and the expected result is appearing on our debug log file, then our compiled Apex classes information is going to be stored in metadata repository. Okay, so right. So this is the syntax for our class. Okay, access specifier, with sharing, without sharing, class name, and write the business logic, define the class members, variables, procedures, or functions. Okay, so yes, this with or without sharing, we will discuss it later. There are a few other concepts which need to be known to you before writing this. So access specifiers are used mm, to define the scope of this particular class. Okay. Right. So as a
In
best
concept, we have only two, right? Public and private.
yeah, we are going to discuss that. We have more.
Yeah. Yes.
Public, private, protected, global. So if you see public, private, protected, these are all present in other programming languages as well, other object-oriented programming languages. But we have another extra one in Apex, that is global. Okay. Yeah, as a best practice, it's always recommended to use Pascal keys. Yeah, starting with small letter, and then the next word starts with a capital letter. That's the Pascal keys. So class name should always be with single word. It does not have spaces. Class name can include underscore. Class name should always be unique with the organization, right? So let's discuss the access specifiers. Okay. So these are the four access specifiers. These are going to define the level of access to the class and its members. Okay. It can be applicable at both class level and member level. Each class and its members can have different access specifiers. So yes. So when I say class, only few features of it can be accessed, but members can have its own access specifiers also. Okay. So there are four types of access specifiers in Apex. That is private, public, protected, and global. Okay. So private, when I say private, members of a class can be accessible within class only, not from outside. And public, we can access outside the class as well. Protected, only the child classes can access. Global, we can access anywhere, and the external systems also, right? So if the user did not specify any access specifier, then it is going to treat The Apex compiler by default, it is going to treat it as private for any members. Okay, so we can define the test classes as private. Yeah, this we'll discuss again later. So public members of class can be accessible within the class and from outside of the class within the organization. So actually, these features where we are defining in our configuration. Does anyone remember? So we are defining the level of access.
Sharings, OWD.
OWD, correct. Right, organization-wide settings, there we are defining our level of access. So similarly, in our programming, we have access specifiers for our classes and its members. Okay. So public members, so public can be accessed within class, outside the class, but not from any other third-party systems. A business logic class should always be defined as public or global. Reason being, we are going to make use of the code again and again. So if we are writing a class, usually it is going to cover almost all most of our business functionality. So by making use of that class only, we are going to, define multiple methods, multiple functionalities. So that's where we will be defining it as public or global. Okay, right. The next one is protected. So yes, protected in the sense as we discuss inheritance. So a parent class, when it is defining the members as protected, it cannot be accessed outside the class, but only the child classes of this particular parent class can access, even though they are an outside class, right? So that's where protected feature comes in. It has been designed for inheritance. Protected members can be accessible within the class and from all the derived child classes. But we cannot access this member from other independent classes. Only the derived or child classes only we can access the protected members. Okay, so global, that one small restriction from third-party systems of public is exposed here. Otherwise, it's same as public. Okay, so global members of the class can be accessible within organization, outside, also integrated with third-party systems. Even from the external third-party system, we can access the class. So that's where we define the class as global. So when we are working on an application which needs integration with a third-party system, so in that case, we need to define our class as global. That's where it would be easy for us to make use of this particular class, which is defined in our Apex programming, to be accessible outside with our third-party system. Okay, so while working with integrations, if you're writing some kind of code for integrations, I would suggest you to define the class as global. Right, so these are the 4 access specifiers in Apex. Ways to define an Apex class. Salesforce provides the below 2 ways to define an Apex class, right? So by using the standard navigation, click on setup, Apex class, in quick find box, write the Apex code inside the editor, click save. This is one way. Yeah, this one we were not using because this was in mostly used before when we were not having the Lightning experience. Yeah, but again, we can use it. So the second one is the developer console. We go ahead and write our class code on our developer console. Let's open. Yeah, I opened the developer console. So here, if you see, if you click on open, you can see the classes, right? So these are all our classes. Okay. If you want to open, you can just click. So this is how our class looks like. So usually we define the class with public keyword. Yeah. as I recommended, if you are working on an integration project, probably global would be the best access specifier. Okay, so we can see all our classes here. So whenever we save we write any code here and then save it, it's going to be stored in the Apex class object. Okay, so it will be shown here in our list. Yeah, we are going to write some classes. So we haven't written anything, right? Triggers. So you can see the pages. Pages means visual force pages. Page components can be Lightning Web components as well. Objects, static resources, packages. Okay. Yeah, you can go ahead, click on new, and you can see all the applications which you can. So now when we are going to write an Apex class, we are going to click that, click on Apex class, and it will ask us to give a name. So, and it is going to save with that name.apxe extension in our Apex class object. So yes, we can create Apex trigger, visual force page, and Lightning applications also from our developer console. But yes, recommended is VS Code editor for Lightning Web Components. Okay, right. So this is how we can, so on the developer console, editor, file, new Apex class, and enter the sample code. You have to give the name first. Okay, so let's go ahead and do new class, enter the name of the class. I'm not writing anything here, so I'm keeping as dummy. Okay, and it's going to create a template, public class dummy, and here is where I have to write my code. But yeah, and then you click on save, Control S, and it is going to be saved. Let's say, okay. This is just a demo. So save, you can do Control S as well. I want to show you some more. Okay. Test. I'm creating a new class. Okay. So before saved here, if you see, there is a star mark. So once I save it, that star mark is going to be disappeared. I'm clicking on Control S, saving, and it's saved. Okay. So this is how it appears. So now our dummy class is saved, right? Let me close this. Let me close this. And let's go ahead and open our class. Go to classes, right? So ours is starting with D, it's dummy class. Let's go ahead and open. Okay, so this is how, and you see the extension dummy.apxe, the class name.apxe. That's the extension. So you can create a new class, write the code in it, and save it. Okay, and how we are going to execute, we are going to see that. Okay, so let's write a small Apex class, a simple one. Yeah. Okay. So we will talk more on objects as well, and then we will be executing the classes with the help of objects also. So simply, we will be defining a class, define an Apex class to manage employee details, define the required variables with the data type. Okay. So yes. Okay. New Apex class, employee details, and click on save. Okay. And it is going to create our class. So this is how a class looks like. For better readability, use the tab and define the variables. employee details, okay, public integer employee code, something like that. Employee code and employee age. So like this, we can define the variables. See here, if you see, if there are any errors, it will be thrown. Okay. So now nothing. So till we were not putting this, there was some problem. Public So I'm just copying it from already available code. Okay. Right. So like this, we can define our variables, public integer employee code and employee age, and public string employee name, designation, email ID, contact number, public decimal, salary amount. Yeah. Based on the requirement of that particular variable, we are using the different data types. Public date, joining date, birth date, public boolean is active. Okay, right. So this is our employee details class. So we let us go ahead and save here. If you see the star mark, click save and it is saved. Okay, so this is how we can write our class code in Apex. So go to classes. What's our class name? Employee. So it's E, employee details, right? So this is our class. So it is saved. So how we are going to execute? Yes, we will be talking more on the objects. So how we are going to instantiate our object uh, and then write a code for our objects as well. So how we are going to do that? We are going to discuss in detail in our uh, next class. Okay. So simple assignments, I have 2, 3, and all of them are similar kind of assignments. File, new Apex class, and this class name is employee helper. Okay. So this is our public employee helper class, which is having all the details. So let's click on save. This is one other simple example. The third one is define an Apex class to manage product details by the required fields. Okay. So our class name is product details helper. Yeah, the class name should start with capital letter. That's called the Pascal case. Okay, right. So public details, sorry, product details helper and the product details. And we are just defining the variables in our class. And we are going to save it. Okay. So let's go ahead and open our product details classes, employee details, employee helper. We see those classes and then product details helper. Yeah, we can open that class. So these are the simple examples to define the classes. Okay. Right. So for today's class, what we have discussed is we have discussed What is object-oriented programming? What is a class? What is an object? And object-oriented programming features the four principles, that is encapsulation, abstraction, inheritance, and polymorphism. Yeah, these are again all basics. And how we are going to achieve each of this principle, we are going to do a practical example through our programming. So class, and how a class is created, how a class is stored, how a class is saved, and what's the extension of a class. Okay, class code file, and how we are going to define the class, the syntax. And then we have discussed on access specifiers, private, public, protected, global. And then how we are going to write a class. So we are going to write our class using our developer console, and then new Apex class, give the name, and then it is going to give the skeleton for you. So you will have to write the complete code of Apex class. Right. So these are all simple examples of Apex classes. Okay. So yeah, tomorrow we will talk more about objects, and then we will be instantiating our objects also. Okay. So we'll be writing code and then executing our code also. So using the execute anonymous window. So we are going to instantiate our class, and we are going to access the members of the class with the help of object. Okay. Right. So this is all for today's class. Yeah.